Hello and welcome to the first video for 6.4. We are talking about inverse trig functions. Okay, we're actually going to start this conversation on the cheat sheet page. Okay, I'm just borrowing an example of a triangle. So I'm going to use the 45, 45, 90 triangle. When we first started this chapter, we were talking a lot about reviewing SOHCAHTOA, right? We had sine, or I guess we actually have written it down already. Over here on the other side, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. But what happens when you turn those upside down? Okay, if I look here, then actually I want to use this one because they're not the same on both sides. Sine of 30 is opposite over hypotenuse. We have 1 over 2. But what were to happen if you were to flip that upside down? You'd get what we call an inverse trig function. And the inverse trig functions get their own names. We're going to go ahead and write those down over here in the boxes. We have our classic 3, sine theta. Actually, we're going to write it this way. Pardon me. Sine theta. We have cosine theta. And we have tangent theta. Okay. When you invert them, remember inverse is the same thing as a reciprocal. So 1 over each of these actually gets a whole new name. Now, if you take 1 over so, right, then you don't get opposite over hypotenuse, you get hypotenuse over opposite. Same thing happens with cosine, hypotenuse over adjacent. And same thing happens with tangent, adjacent over opposite. You get the reciprocal function. Okay, now what you can do with these is a whole other branch of trigonometry. It starts leading into calculus. It's super cool. You get these lines and tangents and things of functions, and they're really, really applicable with some of these inverse functions. And that's where they get their names. So their names are a little strange, but when you invert them, that's all you have to do is you have to take the opposite over hypotenuse and change it to hypotenuse over opposite. The inverse of sine is called secant and is abbreviated to SEC, okay? The inverse of cosine, no it's not. The inverse of cosine is secant, pardon me. Cosine is secant. And the inverse of sine is cosecant, which is abbreviated to CSC. The way I remember that is there's only one co per team. So you've got cosecant with regular sine and secant with cosine. You see how there's only one co? So my apologies on that. And again, the reason comes from more of a higher up trigonometry, but if you'd like to know, be happy to tell you. Tangent is much easier to figure out the inverse for. It's cotangent. So they get their own names. You have secant, cosecant, and cotangent, but basically they're just the flips of the 3 that you already know. So we're going to go ahead and work with these in our triangle trig in 6.4. And let me go all the way down there. You've got that same statement right there written here for you. Let's start by finding all 6 for one measure. Okay, and you're going to find that this is actually pretty easy as long as you know 6.2 and 6.3 pretty well. Okay, all right, so here our theta is equal to 5 pi over 6, and they want to find all 6 trigonometric functions. So what do they actually want us to find? They want us to find sine of, well, you know what? I don't know 5 pi over 6 off the top of my head. Maybe I could go check my cheat sheet, or maybe I could just convert it real fast. It looks like 150. So they want sine of 150. They want cosine of 150. They want tangent of 150, our 3 classics. And then what I like to do is write the other 3 in their opposite format. So cosecant of 150, secant of 150, and cotangent, cotangent of 150. They want us to find all 3 of these. Well, I don't know about you, but I don't know how to find the second 3. We do know how to find the first 3 right now. So let's go ahead and draw 150. It's right about there, right? Drop our triangle. Okay, that triangle is now a 30. Okay, we've got a 30. 30, you've got 1, root 3 and 2, but in this case, a negative root 3, right? Negative root 3. And sine would be 1 over 2. Cosine is negative root 3 over 2. Tangent would be 1 over negative root 3 or negative root 3 over 3. All right, so at least we know how to find those. Now, if you didn't know how to find those, you had no idea what I was doing there, you need to go back and rewatch 6.3, okay? But here, we've got these 3 new functions. Remember, they're the inverses of these 3 functions. What does inverse mean? It means reciprocal. So once you have sine of 150 equals 1/2, you know that cosecant of 150 is 2 over 1, or just 2. If you know that cosecant of 150 is negative root 3 over 2, then you know that its inverse, secant of 150, is going to be negative 2 over root 3. Now, granted, that needs to be rationalized, negative root 2 root 3 over 3, but it is still just the inverse. For the cotangent, same idea. I'm going to take this unrationalized version and flip it, because then I don't have to double rationalize. I just have it on the top now. And so I have negative root 3. That's all you need to do to find those trigonometric inverses. All right, let's do the same thing now for 7 pi over 4. I highly recommend that you pause the video, go try it on your own. If you want to, I'll stop talking for about 5 seconds so that you can go and try it and then come back and see what you get for the answers. All right, hopefully you had a chance to pause the video. We're going to start by figuring out how many degrees this would be. Mostly just because I'm not used to this radian system. Well, I am, but I'm thinking you probably aren't. It's over 4 though, so I would imagine it's probably some version of a 45 triangle. I could be wrong. All right, so do 180, whoops, over pi. The pi's will cancel. That'll be 45, and this will be 315. Okay, so 315 degrees would be exactly halfway in between 270 and 360. And so yes, this does end up being a 45-degree triangle, which means we can use the 45, 45. We have our 1, 1, root 2. Now which one of these is going to be negative? The negative is going to be the y one, right? Because the y's here in this quadrant are negative. And so instead of having just positive, 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 we have 1 positive 1, 1 negative 1. But remember the hypotenuse, that thing's always positive. All right, now we got our 6 trigonometric functions. Let's start with our 3 classic ones: sine, cosine, and tangent, for which I think we may have already done 315. But that's okay, because now we have our triangle. Doesn't matter, I can do it again. Sine is opposite of the angle in the corner. Remember, we built the triangle out of that 45. So we want the opposite of 45, which is negative 1 over root 2, or negative root 2 over 2. Cosine is going to be the adjacent positive 1, or positive root 2 over 2. And then tangent's going to be opposite over adjacent, which is negative 1. Now we'll take those and flip them to find, I did it again, cosecant 315, secant 315, and cotangent 315. And so we get cosecant would be root 2, negative root 2. Secant is going to be positive root 2. And cotangent, when you flip 1 over negative 1, you still get negative 1. And so in this case, cotangent and tangent are going to match. All right, so hopefully you got that correct. This is just an introduction to the inverses. Once again, the inverses themselves, what they're used for is a higher up trigonometric class, okay? We're probably not going to talk too much about what they're used for. Maybe a little bit more after we do Unit 7 and actually talk about what an inverse is in general. But right now, we just need to be able to be really comfortable with knowing how to find them so that when you have those discussions, they're quite easy. All right, so we're going to do a bunch more examples. Pardon me, I'm trying to scroll down. The rest of this section is kind of summing up all of the things that you could get with trig functions and trying to find the exact values of trig functions. You could have an inverse being asked of you. You could have negatives. You could have radians. You could have things that are greater than 360. And we're going to look at all those in the next video. I'll see you there.